So what we're talking about here is finding this missing angle. So in a triangle, what do these three angles always add up to? 180. Remember, we've talked about that this year already. In a triangle, the three angles always add up to 180. Of course, if it's a flat triangle, that's the way it is. And that's the way all these are. So how am I going to find this missing angle right here? Okay, so that's the way that I do it is I just start with 180 and I subtract 65, subtract 57. And so plug that in. What do you get for the missing angle there? What is it? Heard somebody say it? Is 58 degrees. That's right. Okay, number 2, I'm looking for this missing angle. So this angle's 90, this angle's 40. How big is that angle down there? Okay, it's 50 degrees. All right, on this one. All right, Chris, how big is this angle right here? Okay, 30. 180 minus 130 minus 20, and that gives you 30. Okay, then on number 4, how big is this angle? 45. Okay, it's 45 degrees. Okay, so that's going to lead us directly into this. So we know in a triangle that the three angles add up to 180. That's something you should have known from like 5th or 6th grade. Okay, three angles of a triangle always add up to 180. Today what we're going to talk about is how do I know what the angles add up to in any shape, not just in a triangle, but anything. Whether it has 3 sides like a triangle, or whether it has 100 sides or whatever. Okay, so first of all is this thing right here, what we just talked about. In a triangle, how many total degrees is there? In one triangle, how many total degrees, those three angles together, what is it? Okay, 180 degrees, all right? So what we're going to do is I want you to take your warm up and just basically fold it over a couple of times like this right here. Okay? Fold it once, fold it twice. That way you get a good straight edge to draw against. Now, what we're going to do is we're going to follow these instructions. We're going to draw all the diagonals we can from one vertex, okay, from one corner. So what I'm going to do is I'm going to start up here in this corner, or I'm just going to do it from this one corner. I'm going to draw all the diagonals that I can. So when I say diagonal, I mean from corner to corner, or from vertex to vertex. Okay, so I'm going to draw from there to there, just like that. Can I draw any more diagonals in here from this vertex? No, because if I draw to that vertex, that's just a side that's already there, and same thing, I can't draw any here. Okay, now let's go back and think about this. How many sides does this original figure have right here? 4 sides, okay? It has 4 sides. What do we call a 4-sided shape just in general? Yep, I think somebody started to say it. Okay, if it has 4 sides in general, it's just called a quadrilateral. Okay? Quadrilateral has 4 sides. Now, in this quadrilateral, when I drew this diagonal right here, I split this quadrilateral up into what? To what? Yeah, I split it up into triangles, right? And I'm doing this for a reason because we know what the angles of a triangle add up to. So we're going to something that we know that's already been established before. Okay, so whenever I drew this diagonal using this method, how many triangles did we make in this quadrilateral? There's 2 triangles. Okay, now all the angles of this triangle are out on the edge, so they're where we need them to be. Now each one of these triangles has a total of how many degrees? Each triangle has a total of how many degrees? It is 180. Okay? There's 2 of them in here. So each is 180. How am I going to find the total number of degrees for this shape? There's two triangles, and each one of those triangles has how many degrees? 180. Okay, guys, we're about to need to get up and do some jumping jacks or something here. I need y'all paying attention, please. So we have two triangles. Each one's 180. How many total degrees is that? Is what? It's 360 degrees. So in any quadrilateral, if you add the four angles up of that quadrilateral, those four angles, they may not be the same, they may be the same, but whatever they are, those four angles will always add up to 360. Okay? All right, next one. How many sides does this have? 5. All right, and what do we call it when it has 5 sides? Five-sided shape is what? Starts with the P. Pentagon. Yes, pentagon. Pentagon. Here's you some 3rd or 4th grade knowledge. Needs to be dropped on you there. So, pentagon. Okay, now I'm going to do the same thing. And this time I'm going to start from this vertex right here. I'm going to draw all the diagonals I can. Okay? From corner to corner, from vertex to vertex. So I'm going to draw from here to here. And from here to here. Can I draw any more diagonals from this vertex? Nope. How many triangles did we make here?
3.
Made 3 triangles. Okay. Good. So each triangle is 180 degrees. In this one, there's 3 triangles. So I'm going to do 3 times 180. So how many total degrees? 540 degrees. So in any pentagon, if it's 5 sides, whether it's like this where it looks like it's, all the sides are the same, or if it's irregular, whatever, if it's a pentagon, if it has 5 sides, those 5 angles always add up to 540. All right, next one. How many sides does this have? 6. What do we call that?
Hexagon.
That is a hexagon. Okay, so I'm going to do the same thing. I'm going to start from this vertex. I'm going to draw all the diagonals that I can. Okay, when we did that, how many triangles did we make inside of this hexagon?
4.
There's 1, 2, 3, 4 triangles. Each triangle has a total of 180 degrees. So 4 times 180 is 720. Okay, so again, in any hexagon, the 6 angles will always add up to 720. Just like in a triangle, the 3 angles add up to 180. Okay? Any hexagon, the 6 angles always add up to 720. All right, let's do it with one more shape. All right, how many sides does this thing have?
8.
So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides. 9 sides. What do we call a shape with 9 sides? This is a weird word.
I don't remember.
It is a nonagon. Okay, nonagon. N-O-N-A-G-O-N. Weird word, but that's what it is, nonagon. All right, so I'm going to start from one vertex here. Start from right here, and I'm going to draw all the diagonals that I can in here. There to there. There to there. So how many triangles did we make?
7.
7 triangles. Seven triangles. Each triangle is 180, so I'm going to do 7 times 180.
1,250.
Is what?
1,260.
1,260. Okay, so again, in any nonagon, if a shape has 9 sides, those 9 angles always add up to 1260. 1,260 degrees. Now, that's just 4 shapes, okay? what I want to do is I want to figure out how can we know what the total number of degrees is in any shape, okay, in any polygon, whether it's got 4, 5, 6, 7, 8, 9, 10, or 100 sides, or 1,000 sides, whatever. So what I want you to do is let's look back on this and let's think there is a pattern that's going on here. I want to see if you can figure out what the pattern is.
-2.
What's -2?
Number of sides to the triangle.
Okay, good. So notice from the number of sides to the number of triangles, it's -2. See, there's 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. 9 sides, 7 triangles. So the number of triangles is always 2 less than the number of sides. Which makes sense, really, because if you think about it, from any vertex, 2 of the sides are going to be gone because you can't draw a diagonal from here to here or from here to here. So there's always going to be 2 less, okay? There's always going to be 2 less here than there is here. So what we're going to do is we're going to write a formula here. We're going to kind of come up with this on our own here. But one thing I want to do is we're going to talk about one variable. So n in this is going to represent the number of sides. Make sure you get this down. N represents the number of sides. Okay, now to find the total number of degrees, the way we found this is by doing what, really? Finding the number of triangles, exactly. Now, from the number of sides, how do I find the number of triangles? I subtract 2. So how would I write that using the n? Good. So it's going to be n minus 2. Remember, n right here represents the number of sides. So again, what does n minus 2 tell me about this shape? This tells me how many triangles we can draw in there. Okay? Now from the number of triangles, how did we find this total number of degrees? We took the number of triangles and multiplied it by 180. Good. So n minus 2 tells me how many triangles are inside of there. Then each triangle is 180, so we take that number of triangles times 180, and that tells me the total. Good. So that's the formula right there. If you were to Google that, how do you find the total number of degrees in a polygon? You're going to see this exact formula right here. Okay. So in a decagon, first of all, how many sides does a decagon have? It has 10 sides. Yes, a decagon has 10 sides. Okay, in a triangle, the 3 angles add up to what? Good. They add up to 180. In a decagon, the 10 angles add up to what? Okay, that's where we're going to use this thing right here. So I'm going to go 10 minus 2 times 180. And you have to put that 10 minus 2 in parentheses. Okay, I want you to type that in your calculator. I want to come around and see that in everybody's calculator. Make sure you put that 10 minus 2 in parentheses. Make sure you put 10 minus 2 in parentheses. Go. So how many total degrees are in a decagon?
1,440.
Okay, so 1,440 degrees total. So all 10 angles in a decagon always add up to 1,440 degrees. Okay, next, a 15gon. That's just a polygon with 15 sides. At some point, you just have to start calling polygons by the number of sides. You can't give a name to everything. Like, what would you call a shape that has 103 sides? Or would you call something that has 756 sides? I mean, you can't have a name for everything. So at some point, you just start saying it by how many sides it has. So a 15 gun has 15 sides. So I'm going to do 15 minus 2 times 180. So if you were to add all 15 angles up inside of a 15 gun, what do those 15 angles add up to? Is what? 2,340 degrees. Okay, in a 24 gun, what do the 24 angles add up to? Be careful.
Oh, look, my bad. 3,100.
There you go. Okay, good. And I heard the other person said I got it right. I heard you. 3960. Okay. So that's actually really useful because it tells us, you can just use that. It's a very simple little thing. It tells us what the total number of degrees in any shape are. Okay. So let's think about this thing right here. How many sides does this have? 4 sides. What would we call this?
1.
Okay, good. This has 4 sides. We would call this a quadrilateral. Okay? 4 sides is a quadrilateral. Now, in a quadrilateral with 4 sides, what do the 4 angles always add up to? Which actually, we already did that on the very first one. In any quadrilateral, 4 sides, what do the angles add up to? To 360, okay? But let's say I get to this problem and I have a brain fart and I just forget, okay, what do those add up to? Well, just use this formula right here, okay? There's 4 sides, so I'm going to do 4 minus 2 times 180. What is 4 minus 2 times 180? It's 360. So these 4 angles are going to add up to equal 360. So what I want to do here is I want to find the value of x within this problem here, within this quadrilateral. So what I'm going to do is this, is I'm going to add all 4 of these up to equal 360. So I'm going to start off with this angle right here, 85. And I'm going to go ahead and just put it in parentheses just to show them all differently here. So 85 plus this angle, 6x plus 22, plus this angle, 69 degrees, plus this one, x plus 37. Okay, and when I add all 4 angles of this quadrilateral up, what do these 4 angles add up to? To 360. So all I did is I just took all 4 of these, this, plus this, plus this, plus this, to equal the total of 360. And then from here, it's just algebra. Okay, so we're solving for x. So I've got a 6x and a 1x. So 6x and 1x, how many x's is that? So 7x. And then the rest of these, 85, 22, 69, and 37. Just type those in your calculator. Just add those 4 numbers up quick. 85 plus 22 plus 69 plus 37.
213.
And that gives you 213 equals 360. We're just solving for x here, so what's next? Subtract 213. Okay, this zeroes out. I have 7x left on this side. Over here, what's 360 minus 213? Is 147. Then what do? Divide by 7 on both sides. These 7s cancel the 1. And 147 divided by 7 is 21. So x is 21. And that's what I want. And if I want to know what these angles are, I can take that 21 and just plug it back in and see how big those are. But we're going to leave it like that. That's what I want to do for right here.